Welcome. Today, we're going to tackle one of the most fundamental rules in all of algebra, distributing exponents. Now, it seems pretty simple, but there is a sneaky trap that catches almost everyone at some point. By the end of this, though, you'll see it coming from a mile away.
Okay, let's just dive right in, head first into the single biggest mistake people make with exponents. I'm telling you, if you can nail this one concept, you're going to save yourself a world of trouble later on.
So take a look at this equation right here. It kind of feels right, doesn't it? I mean, you just take that little 2 and pop it onto everything inside the parentheses. But is it actually correct? Just think about that for a second.
If you had a gut feeling that something was wrong there, you were absolutely right. And this brings us to the one rule, the golden rule, you just can't forget. You do not, I repeat, do not distribute an exponent over addition or subtraction. That's a special job reserved only for multiplication and division. So why? Why doesn't it work?
Well, just think about what an exponent actually means. Squaring something means you multiply that entire thing by itself. So x plus 2 squared isn't about squaring the x and then squaring the 2. No, it's the whole thing, the entire quantity of x plus 2 times the entire quantity of x plus 2. See the difference?
So if that's the wrong way to do it, what's the right way? Well, to figure that out, we need to unlock something called the power rule. And you're about to see it is all about multiplication. So here's the official rule, the power rule of products. And what it says is that when you have things multiplied together inside parentheses, and that whole thing is raised to a power, then you can distribute that power to each factor. The key word there is factors, things being multiplied together. And you know what? We can prove it really easily just by expanding it out. So if you've got ab squared, that's just ab times another ab. And since with multiplication the order doesn't matter, we can just rearrange the letters to be a times b times b, which, of course, is just a squared times b squared. See, the logic is perfect. And this slide right here, this puts it all together beautifully. On the left side, you see the rule working exactly as it should. With a product, 2x squared becomes 4x squared. Perfect. But on the right, you see that classic trap with a sum. 2 plus x squared is absolutely not 2 squared plus x squared. This comparison, this is the core idea you have to lock in.
Okay, theory is great and all, but let's make this real. Let's make it concrete. We're going to walk through a couple of examples to really see these rules in action.
All right, first up, we've got what's called a power of a power. We have x to the 4th, and that whole thing is raised to the 3rd power. The rule here is simple. You multiply the exponents. So we just do 4 times 3, which is 12. And that gives us our final answer, x to the 12th. Easy as that.
Okay, now let's add a coefficient in there because this is a classic spot where people make mistakes. Remember, that little exponent on the outside applies to every single factor inside. So first you take care of the number. 3 squared is 9. Then you handle the variable by multiplying its exponents. 5 times 2 is 10. Put them together and you get your answer, 9a to the 10th.
And hey, don't worry, this same logic works perfectly for division too. It's called the power of a quotient rule, and it just says you can distribute the exponent to the top of the fraction and to the bottom of the fraction.
And here's what that looks like in practice. We've got 2/3 all raised to the 4th power. So we just distribute that 4 to the numerator and the denominator. 2 to the 4th power is 16, and 3 to the 4th power is 81. And that's our final answer, the fraction 16 over 81. So, let's just quickly recap the big mistakes you want to avoid. First, don't forget to raise the coefficient, the number out front, to the power. Second, when you have a power raised to another power, you multiply the exponents. You don't add them. And finally, the biggest one of all, you never, ever distribute an exponent over addition or subtraction.
So at this point, you might be thinking, okay, that's cool, but is this just some exercise for a math class? And the answer is, absolutely not. Let's take a quick look at how exponents are pretty much running the world around us. You've probably heard of Moore's law, right? It's that idea that describes the exponential growth of computing power. You know, the reason our phones get so much faster every year? That's exponents at work. The very device you are watching this on is a product of this principle.
And what about money? Well, in finance, exponents are the magic engine behind compound interest. It's how a tiny investment can, over time, grow into a really large sum of money, all thanks to the math of exponential growth. Exponents are also absolutely critical in biology. They're used to model population growth. They help scientists understand and predict how populations, everything from tiny bacteria to large wildlife, can expand at an explosive rate. And finally, exponents help us make sense of our world when the numbers get, well, huge. Scales like the Richter scale for earthquakes or the pH scale for acidity, they're built on powers of 10. They let us take these gigantic, hard-to-compare values and turn them into a simple, manageable scale we can all understand.
Wow. Okay, so we have covered a lot of ground. Let's boil this all down to the absolute essentials, the things you really need to walk away with.
Think of this slide as your ultimate cheat sheet. When you see a product raised to a power, go ahead, distribute. When you see a power raised to another power, you multiply. But when you see a sum, an addition sign, inside those parentheses raised to a power, you stop. That is the one you never, ever distribute.
And there you have it. That's the one rule for distributing exponents that you just can't forget. You've totally got this. So the only question left is, what are you going to conquer next?